Welcome to Study Loop.
For this problem on the topic of waves and sound, we are given the speed that a water skier is moving at, and we are told that when she skis in the same direction as a traveling wave, she notices an upward spring in a given time. When she skis in the opposite direction to the direction in which the wave moves, she springs upward in a different time in response to the crests. Now, the speed of the skier is greater than the speed of the wave, and we are asked to calculate the speed and the wavelength of the wave. Now, when traveling with the waves, the skier sees the waves to be traveling with a velocity of Vw minus Vs with a period of 0.6 seconds. So if we suppress the units, we can find the distance between crests in meters, which is the wavelength. Lambda is equal to the resultant speed, Vs minus Vw, over the frequency or multiplied by the period t1. And this is equal to the speed of the skier, which is 12 meters per second, minus Vw, which we don't know, times 0.6 seconds, which is the period. And so this simplifies into 7.2 minus 0.6 Vw. And we'll call this equation 1. So we have an equation with two unknowns, the wavelength and the speed of the wave. So similarly, when the skier travels in the opposite direction to the waves, we have lambda is now equal to Vs plus Vw times the second period t2. And this becomes 6 plus 0.5 Vw. So now we have a second equation with the same two unknowns, the wavelength of the wave lambda and the speed of the wave Vw. So we can solve these two equations simultaneously, and we can find both these unknowns. So if we solve 1 and 2 by subtracting equation 2 from equation 1 and solving for Vw, we get the speed of the wave Vw to be 1.09 meters per second. Now that we have the speed of the wave, we can find the wavelength lambda. So going back to equation 1, and we substitute the value for Vw back, we get lambda is equal to 6.55 meters.